Creating a RESTful API is a fundamental skill for any developer. It enables software components to communicate over the internet efficiently. In this session, we're going to dive deep into the principles of REST. Don't worry if you're new to this, I'll walk you through it step by step, and we'll learn how to design a RESTful API. Plus, we'll implement it using Spring Boot, which, by the way, is a fantastic framework for building Java applications. So, first things first, let's break down what REST is all about. REST stands for Representational State Transfer, and it's an architectural style that uses standard HTTP methods like GET, POST, PUT, and DELETE to interact with resources. But what does that mean in practice? Simply put, it allows different systems to request and exchange. Creating a RESTful API is a fundamental skill for any developer. It enables software components to communicate over the internet efficiently. In this session, we're going to dive deep into the principles of REST. Don't worry if you're new to this, I'll walk you through it step by step, and we'll learn how to design a RESTful API. Plus, we'll implement it using Spring Boot, which, by the way, is a fantastic framework for building Java applications. So, first things first, let's break down what REST is all about. REST stands for Representational State Transfer, and it's an architectural style that uses standard HTTP methods like GET, POST, PUT, and DELETE to interact with resources. But what does that mean in practice? Simply put, it allows different systems to request and exchange data seamlessly over the web. Now, let's get into the nitty-gritty of designing our API. Start by defining your resources. Think of them as the data you want to expose. For instance, if you're building a library system, your resources might be books and authors. Each of these resources will have a unique identifier, usually an ID, that helps in accessing them specifically. Once we've mapped out our resources, we can move on to defining the endpoints for our API. Each endpoint corresponds to a resource action. For example, to get all books, you'd use a GET request at the /books endpoint. Similarly, to add a new book, you would send a POST request to the same endpoint. Okay, now let's talk about how to implement this using Spring Boot. First, you'll want to create a new Spring Boot project. Open your IDE and either use Spring Initializer or your preferred method to set up the project structure. Make sure to include necessary dependencies like Spring Web and Spring Data JPA, which makes working with databases easier. Now, after setting up, let's create a model class for our resource. For the book example, create a class called Book with attributes like ID, title, and author. Then, we'll need to create a repository interface to handle database operations. Just extend JPA repository and voila, you're ready to interact with your database. Next, we create a controller class that will manage our HTTP requests. In the controller, you'll define methods annotated with GET mapping, POST mapping, and so on to handle different operations. Don't forget to include proper response statuses for each method, providing clear feedback for the users of your API. Now, once you've got all this in place, simply run your application and you'll have a fully functional RESTful API ready to serve requests. Pretty cool, right? So there you have it. We've covered the essentials of creating a RESTful API using Spring Boot. There's a lot more to explore, like authentication and error handling, but that's for another session. For now, go ahead and experiment with what you've learned today. Let's start by discussing what REST actually is. REST stands for Representational State Transfer, an architectural style that defines a set of constraints for creating web services. Imagine you're ordering a pizza from your favorite pizzeria, right? You have several options. You can call them up, visit them in person, or even use an app. Using an API is somewhat similar. You send requests and receive responses just like when you're ordering your pizza. These requests utilize HTTP methods such as GET, POST, PUT, and DELETE to communicate with the server, much like the various ways you might choose to communicate your pizza order. Each method has its own purpose, folks. For example, when you want to get details about your pizza, you'd use GET, right? And to place an order, you'd go with POST. So as we dive deeper into this topic, just remember, APIs are the bridges that connect your applications with the web services out there, allowing them to interact seamlessly. We'll begin by adding the essential Spring Boot Starter Web, which, simplifies the setup for building web applications, especially if you're looking to create RESTful services. This starter brings in necessary libraries like Spring MVC, which helps us handle HTTP requests and enables various web functionalities. Next, we'll include Spring Boot Starter Data JPA, which seamlessly integrates Spring Data JPA, allowing us to perform database operations without needing lots of boilerplate code. To facilitate our in-memory database interactions, we'll also add the H2 database dependency with a runtime scope. This is really handy because it lets us store data temporarily while we're developing our application, making it super convenient to test our API's functionality without needing an external database setup. Each of these dependencies plays a critical role, ensuring our application is well equipped to handle web requests and effectively manipulate data. So this configuration, it sets a solid foundation for building our RESTful API using Spring Boot. Next, we're diving into the implementation of the book model, which represents the data structure for our API. So, the book class is annotated with @entity, which means it is a JPA entity that will be linked to a database table. Within this class, we define the key attributes of a book: ID, title, author, and ISBN. Now, the ID attribute, marked with the @ID annotation, serves as the primary key for the entity, while the @generated_value annotation ensures that the ID is automatically generated by the database. This is super important for keeping unique identifiers for our books. Okay, let's add some getters and setters for these attributes, right? They're essential for easily accessing and modifying the properties of our book entity. This encapsulation makes data manipulation a breeze. Next up, we will create the book repository, which is an interface that extends JPA repository. This integration lets us take advantage of built-in CRUD operations, such as saving, finding, and deleting books, without needing to write additional boilerplate code. This really streamlines our interactions with the database and enhances overall development efficiency. Now, let's implement the book controller, which will serve as the backbone of our API, handling various HTTP requests for book management. We begin by annotating the class with @REST_controller, which allows it to respond to web requests with JSON data. The @request mapping /API/books annotation sets the base URL for all endpoints in this controller. Next, we inject the book repository using @AutoWired, enabling us to easily interact with our database. The first method, getAllBooks, is mapped to a GET request and retrieves all book entries, returning them as a list. For adding new books, the createBook method accepts a JSON representation of the book, saves it to the database, and returns the created book along with a 201 status code. Now, to update existing books, we have the updateBook method, which extracts the book ID from the URL and updates its details based on the provided JSON data. Lastly, bookdelete allows us to remove a book by ID, confirming the deletion with a 204 status code. Through these methods, we facilitate full CRUD functionality, effectively managing our book resources. We begin by creating the resource not found exception class, which extends runtime exception. This custom exception will allow us to provide specific feedback when a resource, like a book, cannot be found. By annotating the class with @response_status HTTP status.notfound, we instruct Spring to return a 404 not found response whenever this exception is thrown. This is crucial for user experience because generic error messages, they can really be confusing. Instead, our custom message will inform clients about the specific resource that was not found, thereby improving the clarity of our API's responses. Now, the constructor takes a string message as an argument, which allows us to pass detailed information regarding the error. This level of specificity helps developers understand what went wrong during their interaction with the API. Overall, this implementation aids in effective communication between the client and server, significantly enriching the usability of our RESTful services. By employing this approach to error handling, we ensure that our responses are both informative and user-friendly. Now that our RESTful API structure is established, let's see how we can implement functionality to add a new book. we're going to set up a post endpoint, which is super important for handling incoming requests to create a new book entry in our database. First up, we'll define the createBook method within the book controller class. This method is mapped to the post HTTP method, so our API can accept data in JSON format. Next, we'll utilize the @requestBody annotation to bind the body of the request, which contains the book data, to a book object. Once we receive that object, we'll call this save method from the book repository. This method interacts with the database to persist the new book. When the book is successfully created, we return a response that includes the saved book's details, along with an HTTP status code of 201, which indicates that everything went smoothly and the resource has been successfully created. Now, don't worry, we've also set up a method called getAllBooks, which is mapped to the getHTTP method. This method retrieves and returns a list of all the books stored in the database, neatly formatted in JSON. By implementing these functionalities, we're enabling critical actions like creating and retrieving books, which are absolutely essential for our API's usability and efficiency. So, there you have it, a fantastic way to enhance our API.
Next, we will implement a configuration class to enable CORS for our API. This is crucial when your front-end runs on a different domain or port, as it allows the front-end to interact with the back-end without running into cross-origin issues. Here, we define a class annotated with @configuration to specify that it provides Spring configuration. By implementing Web MVC Configurer, we gain the ability to customize the Spring MVC configuration. Now, let's take a look at the method addCorsMappings. Within this method, we use CORS registry to specify which endpoints should allow cross-origin requests. In this example, we target all API routes by using the mapping pattern /API//, and we enable CORS requests specifically from HTTP localhost 3000, which could be adjusted to your front-end's URL. Additionally, we allow standard HTTP methods get, post, put, and delete, ensuring that our API can handle all necessary interactions with the client. By adding this configuration, we ensure seamless communication between our front-end and back-end during development, preventing potential errors and enhancing user experience.
First things first, we add the SpringFox Bootstarter dependency to your pom.xml. What this does is enable the automatic generation of interactive API documentation, which is pretty awesome for developers who will interact with your API. All right, moving on. Next, we need to create a configuration class to set up Swagger. This class will have the @configuration annotation, which tells the Spring container that it's got some configurations to process. Then, we toss in the @enable Swagger2 annotation to activate Swagger support, allowing us to tap into its features. Now, let's define a docket bean. This is where we specify all the important details for generating our API documentation. Using requesthandlerselectors.base package, we'll designate the package where our API controllers live, making sure that Swagger only documents the relevant endpoints. And don't forget about the paths method, which lets us select all paths, ensuring our entire API is included in the documentation. Once everything's configured, just run the application and voila! You'll expose the Swagger UI endpoint at http://localhost:8080/swaggerui/. From there, you can visually explore all API endpoints, test requests, and view expected responses directly in your browser. This makes it so much easier to understand and interact with the API. Pretty neat, huh?
In conclusion, creating a RESTful API with Spring Boot is really about setting up your project first. You'll define your models, repositories, and controllers. Then you can handle errors effectively. Don't forget to configure CORS and add some documentation along the way. It's a straightforward yet powerful approach, like building blocks that enable communication between different software components over HTTP. Now you've got a solid foundation to build upon and customize according to your application's requirements. So keep experimenting. Each time you build an API, it's a fantastic chance to enhance your skills and broaden your knowledge. Happy coding!